Yeah, good afternoon, everyone. Dear students, as a part of GC E-Connect series of e-lectures, today I'll be presenting you all with the module 2 of my subject, Prestressed Concrete. Before starting with the module 2, let me brief up with what we have done in module 1. In module 1, we have studied about introduction of PSC, we have studied its comparison with RCC, and we have finished with 4 methods of analysis of prestressed concrete. Now in module 2, we will be dealing with deflection of beams. The presentation series for this module is been divided into 3 videos. The first video is the one in which you will be introduced to deflection, how deflection happens, what are the different causes of deflection, etc. In the second video, you will come across different formulas which we will have to use to solve the numericals, and of course in the third part we will be dealing with the numericals. So let me start with the first video of this module. Deflection. Now, what is deflection? We can define deflection as the vertical displacement of a point on a loaded beam. The maximum deflection occurs where of course the slope is 0. For example, you can see a beam, image of a beam carrying a central point load. So once the point load is applied, in the figure we can see that the axis X undergoes deflection. Of course, as this is a simply supported beam with a central point load, we get the maximum deflection at the center itself. Methods of calculation of deflection. We have various methods which we have studied in the previous semesters, which include double integration method, moment area method, conjugate beam method, or say principle of virtual work. Even application of Moore's theorem can be used to obtain deflection. We have two types of deflections. One is the short-term deflection, second one is the long-term deflection. As the name suggests itself, the short-term deflection is the one which occurs in the earlier lifespan of the beam, whereas the long-term deflection is the one which occurs in the later lifespan of the beam. Short-term deflection. Short-term deflection is caused by initial pre-stressing force, dead loads, and the live loads, whereas the long-term deflection is caused by the pre-stressing force, dead loads, live loads, and along with this the effect of creep and shrinkage causes long-term deflection. Now the important thing which has to be noted here is, while calculating short-term deflection, if losses in pre-stress is given in the problem, the initial pre-stressing force has to be taken for calculation of short-term deflection, whereas to find out long-term deflection, the final pre-stressing force, that is deducting the losses, which already we have done in few examples in the last module, has to be taken for determining the long-term deflection. Now, why should we determine deflection? The serviceability criteria is very important for any structural element. Hence, to determine whether our beam is satisfying the serviceability limit or no, it is mandatory for us to determine deflection. The total deflection in case of prestressed concrete is the resultant of the upward deflection due to prestressing force and the downward deflection due to the gravity loads. Now here we find the difference when we compare an RCC element with the PSC element. In case of RCC element, there is nothing called as an upward deflection. All the deflection is downward itself. Whereas in prestressing PSC members, the prestress force produces a deflection which tries to counterbalance. In my previous lectures also I have always stressed upon the word counterbalance. Prestress force is that force which tries to counterbalance or react to all the actions produced by the loads. So similarly in case of deflection also, the prestress force produces an upward deflection which tries to counterbalance the deflection produced by the loads. Hence, we can see that the PSC elements will undergo a lesser or a lower deflection, a lower degree of deflection we can say, as compared to the RCC members. This permits the use of PSC members for a long span, and also we can have a slender members in PSC as compared to RCC. In case of calculation of deflection, only flexural deformation is considered and any deformation due to shear force is neglected. Factors influencing deflection. There are 8 major factors which influence deflection. This question has been asked in the university question paper for 6 marks, so please make a note of it. The first factor is imposed load and self weight. Second factor is magnitude of prestressing force. Third is the cable profile. Fourth is the modulus of elasticity and moment of inertia. Next is shrinkage and creep. Seventh is the span of the member, and the last one is support conditions. Now, imposed load and self weight. Of course, the major factors which cause deflection are the loading, or say the gravity loadings, in which the imposed load and the self weight play a major role. So here we see the importance of structural design. Self weight of the member is by the virtue of the dimensions of the member. If a member is properly designed, we can have optimum dimensions for the member which reduces or optimizes the self weight. That's where proper structural design comes into picture. The imposed load depends upon the type of structure, and that consideration is taken in the design. Prestressing force. It also plays an important factor in deflection, as we have noted in the previous slides. It acts as a counterbalancing force. Next comes the cable profile. As we know that we have various cable profiles such as horizontal, parabolic, trapezoidal, etc. These cable profiles also play an important role in influencing deflection. Further, the properties of the members such as modulus of elasticity and moment of inertia also have a well-defined role in influencing deflection. Next comes shrinkage and creep. These are the parameters which play a major role in long-term deflection and have to be given a considerable importance. Next are the general factors such as span of the members. Longer the span, generally greater will be the deflection. And next is the support conditions. Now, the permissible deflection limits in case of PSC for upward deflection are span divided by 300, and for downward deflection is span divided by 250. Now here we can easily compare the deflection limits of RCC with PSC. If you remember guys, in our 5th semester in RCC subject, we have studied that the deflection limit for RCC is given by the relationship span by 250 or 20 mm, whichever is the least. So here, in case of RCC, if we have a beam of span up to 5 meters, we get a deflection of 20 mm. But once we go beyond the span of 5 meters, the deflection is restricted to 20 mm itself, because if we divide a 6 meter span by the factor 250, we get a value which is greater than 20, which is not permitted. Here we have advantage of PSC members because the deflection limits are a bit more as compared to RCC. Hence, when discussing the advantages of RCC, we had noted that RCC members are suitable for a shorter span, whereas prestressed concrete sections can be provided over a longer span. And this is the reason, as they easily satisfy the serviceability criteria under deflection, we can use the PSC members for a longer span. This concludes the first video of this module. Thank you.